I've been telling everyone 6:30.
And go. Hold on.
He should be back at what, 4:50?
That's it.
Yeah. Dude, I was looking at the goal line in this Seymour.
Hold on.
It was so bad.
Cynthia.
Very small.
I have a
What's
twice
that?
when I could have scored a goal, but I just can't.
All I had to do was kick it in. Like, there was absolutely no
Get
way
it?
to go. I just had to kick it in.
It's okay. You'll make up win.
pass.
You don't fit in, do we?
Should be on there.
It's made Toronto, New London, and West.
Who's it from?
And then
There you go.
That's it. Then here.
we'll be here. And then are we done?
Olivia.
Is that like our last game?
No, and then we have sectionals. Or regionals.
Oh, our season's
Hopefully we get like last year. Like, I wouldn't mind going to last year.
Jennifer.
Yeah.
Last year, like, who else was in region? Or West of here. I wouldn't mind going this weekend.
He said we'll probably have to go like 2 hours away.
Hold on.
As long as we don't do
Can I grab one of the charging boxes?
Yeah,
first
certainly.
place, something like that. They're in a region where they're like crazy.
Big.
Oh, they went into semifinals for state last
Take a mercy loss.
Excuse me.
year. No.
What?
Okay, that's 2 hours. Cedarburg. There, that's what it's called.
All right, ladies and gentlemen. Take your phones, put them on your desk, or put them in your backpacks. If they're on you when you go into the back, I will not let you do a retake on the test. So your phones need to be left at your desk right now. Pens and pencils left at your desk right now. Over here, ladies and gentlemen, are the answers to version A of the test. Right here are version B, right there are version C. You can look at them all you want. You are not allowed to copy anything down. Okay? So, go check out your answers. Please make sure I added correctly on each page. Please make sure the totals are correct, ladies and gentlemen. Go ahead and look at the answer keys. Please leave writing utensils at your desk. Okay? Thank you very much. So go back there. You can bring your test back, but that's it. Go back and look at them, ladies and gentlemen, if you want to see them. This is a more efficient, quicker way of us doing this than me putting them on the overhead for you. If you have questions, you can call me over. I will explain whatever you need, ladies and gentlemen. Again, double check my addition, ladies and gentlemen. I have been known to make a 10-point error, sometimes in your favor, sometimes not. If I made it definitely not in your favor, you want to let me know so that I can correct it, ladies and gentlemen. Alright, so you got 1 point for the correct state, not for the correct answer. So, here, look at the ratios. These
Oh,
are
yeah,
supposed to
I
be-
just couldn't figure out how to do these, the balance of numbers.
Yeah. So it's 2, 2, and 2. So I gave you the credit, even though you used the ratio, which you got from your balance equation, I gave credit for that. But because that ended up being the wrong answer, that's why it's wrong. Then that carries down, and it carries down. Okay. Yes, sir. What? Those are the ratios.
I'm taking a
These
nap.
are getting the moles into brackets. Oh, that's how many points this is worth. So like the orange highlighter, that's where the point, that's where the form, that's where it belongs.
Oh.
So you get 2 points for these, you can get 1 point for setting up correctly, 1 point for calculating the math correctly, and that's what those are for. I have 4 here.
Yeah,
So like, yeah, sometimes that's what they're correct, if it's like here too, this is supposed to be 41 pounds. Okay, because that's what, the program that writes it, it doesn't always give you the answer to the correct, so it takes go back to the other check. Okay?
If you think there's a problem, you can call me over, we can talk about it, you can put a note on it, turn it back into me, I'm fine with that. I will recheck it, make sure I didn't miss something, because occasionally I do, there's a lot of checks on there and a lot of points. Sometimes I miss something, ladies and gentlemen. Again, if that's the case, all you gotta do is put a note on it, let me know, come and see me after class, come and see me before class one day. I'll be happy to go over those things with you.
And apparently they have like the white chocolate macadamia cold brew or something like that. I really didn't try it. I did. It's pretty good. It's really sweet though.
Well, you
Yeah.
have to do
It's really
it
sweet
for-
though, so if you don't like super super sweet, then. So I thought it was good. I got it with the lemonade.
Here you use 2 people then on.
The only thing is when they made it, they
But
irritated me. I got
you have to do it at the start
Venti,
because
and
this,
it was all ice.
This is the
And then
grain
like
of
this
solid.
whole I was like,
okay? We should
okay, this is not worth the $7.
I'd ask you for an extra bowl, but
Yeah.
I always forget to ask for an extra.
We were just signing papers for all of the, for retiring.
Because like when I see my drink is all ice,
Yes,
like,
because I guarantee you.
if this was how big the cup was, this is how much of it was ice. Like actually, I was
We have a
getting
meeting
annoyed.
on,
Set that right away.
or on Sunday, we have a thing from 2 to 5. It's a picnic, it's not mandatory.
Yes.
But we're giving seniors their schools and
You got like basically.
it's just like welcome the new guy. So when you're in NHS, you get a stole or a graduation. Not a stole. Oh, like the actual fabric stuff. And then we have our. You're not invited.
I had. No.
You're not too
Well,
cool.
I was gonna go.
It wants your PIN number.
Hold on, I'll approve it.
And just kind of what it was and like.
Go ahead.
I think Sophia, you said that the picnic thing is this Sunday, right? I have work, but I have like you know how for volleyball we sell the cookie dough? So Mr. Gadai bought some of the cookie dough for me,
Alright.
and I still have never made it.
I corrected it with the grade report I'm gonna give you, obviously, that's your old grade on that. So.
And give it to you. Can you bring it
Yeah.
for the picnic?
Yeah.
Okay, bet, because
Alright.
I can't go. I have to work at 1:30, so it's crazy.
Hey, we're doing practice on Friday.
I wasn't there. So I took the AP test on Friday, right? And then towards the end of it, like I started getting a headache and everything, but I tried to ignore it. And then by the time that I got like home and everything after eating, it was like a full-blown migraine. And I went and I slept for pretty much the entire day after that.
Did you post our unit 8
For AP US history, I feel like it was
Why do
pretty
you have
good.
grade 7 on top of unit 8?
Because I have to physically switch that in Google Classroom and I haven't had a chance to yet.
Why is my grade high?
No, you find out in July.
Because that's what you got right now.
Oh,
I know I didn't pass the AP program because passing
Oh
for
my
the
God.
AP exam is getting 3.
This is the unit where we have our
I
finals.
definitely got like a 1.
Those-
And then
Or is
I
that
feel like I did really good for English though, so I'm not worried. I'm really excited to find out how I did it. Yep.
Do we have a unit 9?
No,
Yes, this is the unit where we have like the fake periodic table. We
Angel.
have to ask like a Maya and stuff about it.
Yeah.
Your grades down, the only thing you could do is to retake tests to get out. That's the only thing.
Well, the only test you can retake is the Unit 7 one we just took.
And what do you have to get to, you know, retake it?
You have to be in the 60s or lower, any 60%. All right, take a look at your grade report, ladies and gentlemen, that I just handed to you. That is where you're at in the class as of right now. Now, please understand, there is very little left for us, ladies and gentlemen. Okay? I'm trying to think. I don't know if we even have a lab in this unit, ladies and gentlemen. Okay? So, basically, ladies and gentlemen, the Unit 8 test is your final exam. So that means your tests are done.
Is that like the day of the final?
That's the day of the final, yes. So on the day of the final, you will get an hour and a half to do the final exam. Seniors, your final schedule is set up here. For us, it is Wednesday the 29th from 9:11 till 10:22. If you don't finish it at that time, you can finish it on Thursday during class, ladies and gentlemen, for the seniors. Yes, KP, what can I do for you?
I was gonna ask what day are finals.
For you guys, your final is on Friday, June 7th, 7:30 in the morning until 9 o'clock.
7:30 in the morning?
Yes, what time school would normally start any other day.
Oh, yes.
Girl, bye.
So,
It's the
And we
Thursday.
get out early that day too. That's a Friday.
that's Friday. So, questions? All right. Again, if you have any questions on the test, if you have any mistakes that I made in grading or adding it up, just put a note on it, leave it on my desk, put a note on it, come talk to me. I'll be more than happy to double check things for you. The grade report I gave you, ladies and gentlemen, has things highlighted, your current grade, and then if you were missing anything. Now, the only thing that matters if you are missing is labs, because none of you who are in the room right now are missing any quizzes or tests. So, if you are missing a lab, you have until the 23rd, that is next week, Thursday, to get it turned in. If you do not turn in the labs by that time, they will stay at 0 no matter what. If you want to do a retake on this unit test, you have until next Thursday, the 23rd, to do that retake. You need to show me the corrections on the test that you just did. You need to give me at least a day notice so that I can get the test ready for you, and then you need to find a time when you can come in and take it. Okay? If you want to take it during the day, that is fine, but you need to let me know, and it needs to be an hour that I am available. You can be in the room next door taking it while I am in here teaching. I have no problem with that. You cannot use your class time for this class, though, to retake a test from the other unit. Questions? All right. Okay, I hope you paid attention yesterday. I hope you took some notes down yesterday off of the video because I am not replaying it. Okay? I will briefly go through some of the things that were on it, but I am not replaying it. Yes, Ava, what can I do for you?
Oh, wait, never mind. You're handing out the sheet.
Yep,
But
these
there
are the
was that-
worksheets.
There was that one sheet
Ooh,
that,
I need that.
that we filled out, but like, we didn't have it, so are we going over that today?
That one sheet that we filled out.
Well, that
but
we
didn't-
didn't fill out, but your old class filled out, and it kinda looks like this up here. And that was, okay. Are we filling that out today?
This worksheet at the top,
Yeah.
if you want to, you can, but we've already been through all this. This is all stuff that we have already covered in class. You should be able to look at an element on the periodic table and tell me the number of protons, neutrons, and electrons, the atomic number and the mass number of everything on the periodic table. So these again, and again, ladies and gentlemen, the answer keys for all of these are posted online already in Google Classroom. I do need to move Unit 8 up to the top so that when you look at the units, it goes Unit 8, then Unit 7. I'll do that when I get to my desk in a minute. But these are the things that we've already covered this stuff. We're just reviewing it in here because this last unit is on the periodic table, ladies and gentlemen. So let me do this real quick. Class work. Move up. There we go. Class work. Move down. Oops. Move up. Hold up. All right. So, those are the worksheets for this unit, ladies and gentlemen. All right. Next, I'm going to give you all the answers for your test. Plus one extra answer, ladies and gentlemen.
Oh.
Here they are.
You want to make sure to grab it?
There you go. Take one, pass them back. There you go.
Oh my god.
There you go.
Burger and Indian.
There you go.
Orange.
There you go.
Here, there's an extra
Yellow. Green.
You have it. Oh, thank you.
Einsteinium.
By the way, ladies and gentlemen, I do have extra copies of these if you ever need an extra copy of these.
Wait, what the heck is this?
Those are the answers to your test.
Eastium. Who's Dalton? Is that your son?
Who's what?
Dalton.
Nope. Dalton is the guy who started the atomic theory.
Is your son or your daughter in here?
No. Why would I do that? They have nothing to do with science.
Wait, is this a practice test or is this our test?
Those are the answers that are going to go on your final test. Your Unit 8 test.
Are we able to use that on our test?
Yes.
Oh, okay.
Matter of fact, I encourage you to put notes all over it.
Turkey-a.
Because the more organized you are, the easier your test will be. The less organized you are, the better the chance you're going to write a 2 on it like somebody did last trimester. A 2 out of 100.
Oh. Did they pass the class though?
I don't remember.
That's crazy.
Yeah, I know. I don't know how you could do that poorly. By pure accident, you should get at least half of them right.
So we can pull these.
Yeah.
So this is like
I'm
an extra
encouraging you.
PDF
By the way,
table?
it's open note, open book text.
Oh. So we can use our notebooks to take as many notes as you guys want.
Yeah, definitely.
Mr. Brand, Mr. Brand. Mr. Brand, can I get another one of this? Leaf doesn't love it.
Sure. Which one was that, though?
Periodic table.
Okay, but here's the thing. They all are periodic tables. What does it say at the top? Special location. Okay, thank you. Okay.
Explain all of
Yes, I will. That's what we're going to do. I'll go to it. Thank you. Okay. So this last unit, ladies and gentlemen, somebody quickly, name me the third period noble gas.
Nitrogen.
Argon. Period.
Third
Argon.
period noble gas.
Argon.
You weren't in the third period and you didn't give me a noble gas, KP. Other than that, you were right on. Argon. So a question on your test may be the element named after the principal of East High School is the third period noble gas.
Oh, and that's where we put it.
So that is where on a test that looks, answer key that looks like this. No, do not write it here. I'm just giving you
I
examples.
know. That's what I'm saying.
But on here, ladies and gentlemen, on a blank one of these, you would find where argon is, our third period noble gas. And since fercium is the principal of East High School, you would write the symbol for fercium where argon goes on our current periodic table.
So periods go down, families go across.
Boy.
The other way.
Oh, whatever.
Periods go across, families go up and down. Okay? Now,
Periods of count.
the element named after the best chemistry teacher at East High School
Radium.
has
No, board.
4 valence electrons, and it is the most reactive nonmetal. Okay? What family has 4 valence electrons?
-4. 14.
Carbon family. Now, we haven't learned yet which one was the most reactive nonmetal, but which one do you think is the most reactive nonmetal?
Wouldn't it be
What? Germanium's not even a nonmetal.
Wouldn't it be borium? Boron?
Boron is not in group 14.
Oh, 14.
Wait,
It'd
but
be
uranium
SI.
is not a metal.
Your germanium is a metal. It is the low D bold zigzag line. So the most reactive nonmetal in that family is carbon, the one at the top. So that is where you would put what is the element named after the best chemistry teacher at East High School?
It'd be 6.
What element?
Branium.
Branium. The symbol would go where carbon is. 4 valence electrons, most reactive non-metal.
How do
One
we
at the
determine
top.
reactivity?
We're going to get to that. I got to teach you some of these things. Okay?
But you said periods go across, and what was the other one?
Periods go across, families go up and down. The element named after the high point of a wave, it has 16 electrons. What element on the periodic table has 16 electrons?
X.
Sulfur. Now, what is the high point of a wave called?
1 second.
Nope, not 1 second, but close. I'll give you that second, though.
Crest?
Crest.
Crest.
Yeah, KP's right.
Good. Now, Ava, when you get a second, take off your headphones, please. Thank you. My suggestion to you, do you see crest on this yellow sheet?
No.
Find it, crestogen, they're alphabetical.
Oh,
Next to it, I would write high point of a wave. Find the element crestogen. Next to it, I would write high point of a wave, because that's what a crest is, the high point of a wave. Now, obviously, you don't need to write anything next to branium, because I would either give you something like the element branium is a 3rd period noble gas, or I would give you the element named after the best chemistry teacher or your chemistry teacher or something along those lines. I'm the only one on here who's a chemistry teacher, ladies and gentlemen. Ferkium is the only one on here who's a principal of East High School. So you do, why? Because, again, she's not the head principal of East High School yet.
Oh, so you can change
So next year I'll have to change this. You want to be lithium? No?
No.
No? Okay. Anyway, ladies and gentlemen, so these are the clues that are going to go on your answer sheet. The test is 2 parts. Figuring out the location where the clue goes and putting the correct clue there. Some of these people we have not talked about yet. We have not talked about Dalton, the father of modern chemistry.
With lambda.
We have not talked, well, lambda we're going to get to today. You should have got it from last week, from yesterday's video, where they talked about lambda being the wavelength.
I didn't
If
watch
you
it.
weren't here, it is online. You could catch it if you want to.
You said lambda's wavelength?
Lambda is the symbol for wavelength. Lambda is the symbol for wavelength. Now, the point being, ladies and gentlemen, you should, before we are done and taking the test, you should have something written by each one of these, except maybe branium and ferkium. Okay?
So you're gonna say like the.
So I will get to this to defining these, and as I do, I will say,
Red.
on your yellow sheet, you're going to want to pull that out, and you're going to want to put this down.
So for like the crest, you'd say like the high point of the wave
Yeah.
is the noble gas in period 1 or whatever.
Correct.
Oh, okay.
Correct.
Oh, this isn't something like that.
Really? Okay. The element named after the unit of frequency is a.
Well, boy, it doesn't sound that bad after we
Hold
write
on.
all of the notes down.
You're right. It's not going to be, but let's get to a tougher question. The element named after the symbol for frequency displays sp3 hybridization with a tetrahedral geometry.
Okay, you don't know.
We got a long way to go. That's all I'm saying. But by the time I'm done, you should write down on a periodic table where sp3 hybridization is, where a tetrahedral molecule would be, because we are going to describe those. And that, ladies and gentlemen, is where these 2 sheets of paper come in. Okay. On the, yeah, yes, all of this you can use.
Everything you just passed out.
Everything I've just passed out and your online notes. Okay? And your regular periodic table. No, you got the final exam time to do it.
Oh, we're able to have like our computer out during the test.
Yes.
Dude, why is no one listening?
I don't know.
I meant like.
And by the way, I really hope you try to chat bot some of the questions, because I got the weirdest answers when I tried to look them up on chatbot, and I'm like, because it doesn't like the fact that it's an alien periodic table. So anyway, this, ladies and gentlemen, is where you are going to put trends of a family. Families go up and down on the periodic table. So when we talk about everything in group 1 having 1 valence electron, I would probably put it on this periodic table, because that is a trend of a family. This is for trends of a period. So when we say these elements have 1 energy level, like the first period does, that's where you would put that stuff. When I tell you that this is the one for a special place, like the most reactive metal, the most reactive non-metal, where two elements are next to each other, even though their atomic numbers would differ by 11 or by 24. We're going to put those locations on here or on here because those are special locations that are going to be used to help you identify where certain things go on the test. The more you write down, the more organized you are, and the more you pay attention and obviously learn these things, the better off you are going to be. So I have extras of these. You want more? Ask. I will give them to you. Okay? I will give them to you. But I set these up for you so that you could organize by family certain trends and by period certain trends. There may be a lot, there may not be a lot on the period side because there aren't a lot of trends by period. Here, ladies and gentlemen, we will highlight some very special parts on here where you're going to want to put down, hey, these two right here are, even though they're right next to each other, they differ in atomic number by 11. And we'll explain what that means as we go along. Do you have any questions right now? Okay, wonderful, excellent. Then, ladies and gentlemen, all right, get your computers out, get them open, and let's go through a couple of things before we get to today's stuff on electron configurations. By the way, when I put out the videos out there, ladies and gentlemen, I don't put them out there just so that they're out there on the internet. I put them out there so that if you miss something, you can go to them and you can use them.
You post it in like Google Classroom or?
I put in Google Classroom. There is, do you know where the daily agenda is? In the top of the class work page. Mm-hmm. In the daily agenda, along with the daily agenda, which I broadcast on the board every day, right up here, class teaching videos. The video for yesterday is on here. Now, there is a link to the date, which is the agenda, and below it, the video, which is the video from that day. As I'm teaching right now, I'm recording this lesson as we go. So, ladies and gentlemen, you can go to it tomorrow, next week, however long from now, and you can see the video. Okay? Questions? All righty. So, we are going to talk about EMR and relationships involved. We're going to review the quantum number stuff you learned about yesterday, and then we're going to get into electron configurations. So, here we go, ladies and gentlemen. Again, your periodic, your EISN, all organized and ready to go for you, ladies and gentlemen. Whole unit is on the periodic table. All right, so we're going to start with electromagnetic radiation, then we're going to talk about quantum numbers. That was what the video began with yesterday. So I'm going to fly unless you have questions, and then I will answer those questions. All right. EMR stands for electromagnetic radiation. This is energy traveling as a wave. That is what the definition of radiation is. Radiation is not on your yellow sheet. You do not have to worry about it. Okay? What makes electromagnetic radiation unique is that all of the waves travel at exactly the same speed. How fast, ladies and gentlemen? They travel at what we call the speed of light. Now, for those of you who have no idea what the speed of light is, ladies and gentlemen, this is 1 meter. You take 300 million of these. You put them end to end. You turn a flashlight on one end, that light will be at the other end after 1 second. That is how fast light travels. 300 million of these every 1 second. Now, I want you to think about this for just a second, ladies and gentlemen. It will not be on your test, but please think about this. The sun, light from the sun that we go outside and feel on our bodies, that we see, left the sun 8.5 minutes ago. 8.5 minutes. Traveling at 300 million of these every second, ladies and gentlemen. 8.5 minutes is 510 seconds. 510 seconds. At 300 million of these per second, that sunlight is a long way away. Okay? But all electromagnetic waves travel at this speed. Here is a poster, ladies and gentlemen, of what we call the electromagnetic spectrum. This has all the different kinds of electromagnetic radiation. They are also listed up here. And if I were you, I would put this somewhere on one of your sheets in the order that it is here. Why? Because you'll notice that on some of the clues, there is gamma, There are microwaves. I believe there's infrared and ultraviolet. Might be X-rays on that yellow sheet, and there are some colors that are on that yellow sheet. Okay? So let's talk about that. All right? Now, electromagnetic waves are unique because, number one, they don't need anything to travel through, which is good because light from the sun has nothing to travel through, nothing but empty space. And all waves travel at the exact same speed, ladies and gentlemen. That is not true of waves that are what are called mechanical waves. Sound is a mechanical wave. What happens if you take helium in and then talk? Your voice becomes really high. Why? Helium is a less dense medium, and the sound wave actually travels faster through it. That does not happen with electromagnetic waves. Here's the other thing. You get to the beach, ladies and gentlemen. You're excited to get to the beach. You dump your stuff in the sand. You go running into the water. As soon as you hit the water, what happens to the speed you are traveling at? It slows you down because it is a more dense, it is a thicker medium. The same thing happens with waves that are sound waves, not electromagnetic. They all travel at the same speed. Okay? Now, this, ladies and gentlemen, is the different types of electromagnetic radiation. Radio and TV waves are electromagnetic radiation. Radio and TV waves are what I grew up on, ladies and gentlemen. What I mean by that is before cable TV, you used to have to get up from your chair, go over to your TV, and turn a dial to go from channel 2 to channel 5 to channel 11. Okay? You had to physically turn a dial. The greatest day of my life, ladies and gentlemen, was the day we got cable TV as a kid because I had a remote control. I could turn the TV on, I could turn the TV off, and I could change the channel without getting out of my chair. It was awesome. Okay? Until then, if you were watching a TV show and you didn't like it, you had to go walk over to the TV, turn the dial, and find one of the other 3 channels that you liked and watch it. Yes?
Write this on a pink sheet, right?
Write this wherever you wish. Wherever you wish, it is up to you. You can, but again, you want to make it, I don't care. You got to know where to find this stuff. I don't care. Okay? All right. So, radio, you tune 101.1 WIXX, 98.5. Those are different frequencies of the wavelength. When you tune it in, you get to listen to that station. By the way, radio and TV waves going away, but guess what uses the same area? Your cell phone.
Oh my gosh, put it away.
Your cell phone uses that same one. Okay? By the way, ladies and gentlemen, just so you know, you remember how they used to say that there was no harm in lead paint? They used to say smoking was good for your breathing. They used to say that artificial sweeteners didn't do any harm to people. Then they found out artificial sweeteners cause cancer in lab rats. Smoking is not actually good for you. And you know what? Lead is not good for paint, even though it keeps it nice and bright. Over time, we find out that some of the things that we have been doing are not as good for us as we think they are. Well, good news, ladies and gentlemen. When you have a cell phone, you are attracting radiation to your body constantly all day long.
We're gonna die anyway.
Now, please think about where you keep your cell phone. For you, it may be very different than where I keep mine. But there are studies out there that show that men who keep their cell phone in their front pocket have a lower sperm count than those who don't. Coincidence or not? Not sure. I'm done having kids. I don't care. Okay? My wife and I have replaced ourselves. We're good. So, just something to think about. Really freaked me out when my daughter used to tell me that she would sleep with her phone under her pillow at night. Bad idea. Because now that radiation is being drawn to a different part of your body, and I don't know if it's going to be harmful or not. So, keep that in mind. Microwaves are just what we're talking about. The microwaves in your home that heat up food. What do they actually do to the food? Vibrate what part? What particle? The only particle that microwaves affect? Water. They make water molecules move faster. That heats up the food that you are cooking.
That's why if you put dry noodles in there, it'll float.
Okay. Okay. Never done that. Infrared, ladies and gentlemen, is what remote controls work on. Okay? Again, the greatest day of my life was when we got cable TV as a kid. The worst day was when I had my birthday later that year. because my mom used to like to take the birthday cards and put them on top of the TV. We had the big old console TVs, you know, flat top on it. Yeah, the box TVs. She used to put your birthday cards up there because, after all, you couldn't just throw the birthday card away after you got it. So she would put them up on top, and once in a while, she would put them right in front of the cable box. And it no longer allowed your remote to work because that card was thick enough that it stopped the infrared signal from getting to the box to change the channel. Now I got to get up and I got to move that stupid card. Infrared is used for that, for remote controls. Visible light is what we see over our head, ladies and gentlemen. And what we see are the colors of the rainbow, Roy G. Biv. Wow, good job today, ladies and gentlemen, of wearing the most unusual colors we could imagine today. So we will use my blue shirt, ladies and gentlemen. When visible light, white light, hits my blue shirt, it absorbs every color except one. What one? Blue that reflects, and you see my shirt is being blue. Angel has got a black sweatshirt on. So guess what? Light hits that, what gets reflected? None of it. None of it, which makes it appear to be black. Sophia's shirt is white. Light hits that, now all of it gets reflected, and we see white. Which is why, ladies and gentlemen, they will tell you in summer to wear white and not black, because the sunlight does the same thing. That absorbs all the sunlight that hits it. That reflects the sunlight that hits it, meaning that is a cooler color to wear in summer than that one. Red gets reflected. The other colors get absorbed. Browns and things are combinations of the different colors being absorbed and reflected. Okay? Here, ladies and gentlemen, is a spectrum of every element on the periodic table. The fingerprint of every element. The colors that it gives off when it is, or when the electrons are moving around. That is how they can identify elements on those crime shows and things, ladies and gentlemen, because every one of those is unique. Every one of them. Ultraviolet, what's that good for, ladies and gentlemen? What?
Temperature.
No, not temperature. Ultraviolet.
Oh, black.
No. Ultraviolet is good for getting a tan in summer, ladies and gentlemen. Meaning, ultraviolet or UV actually penetrates through your skin and causes chemical changes to the makeup of your skin, causing it to change color. Sign of a chemical reaction. X-rays are powerful enough not only to penetrate your skin, but muscle, tissues, everything except bone, which means you take an X-ray laying your arm on a piece of photographic film, you will see a picture of the bone inside of it because it goes through everything. And gamma is even more energetic and more dangerous, ladies and gentlemen, and that's the stuff they use in chemotherapy treatment for cancer patients.
What does that do?
Wait, so like,
What does it do? That means it kills cells. Kills them. Dead.
are you gonna like further in depth explain the ones that are like on there, or like for gamma rays, should we put next to it used in cancer treatment?
No, what you should put for gamma is what we're about to talk about here, which is, what do you notice? Wavelength decreases as we go from here to there. That is the trend. So, for example, on your list of your yellow elements, which one has the longest wavelength?
Radiance.
Which one has your longest wavelength? Look at your elements on your yellow sheet. Are there radio and TV on there?
No, I think we have infrared, or maybe microwave.
Microwaves. So the question will be, the form of electromagnetic radiation with the longest wavelength is a fifth period alkali metal. So again, I wouldn't write down for microwaves that it has the longest wavelength, but what I would do is copy this down somewhere or have it available and know what happens to wavelength, frequency, and energy as we go across this. Because some clues will simply be the element named after infrared light. Is a element with 7 protons. Some will be very easy. Okay? So, as you go across this, ladies and gentlemen, one of the things that happens is the wavelength, the length of the wave gets smaller. It decreases. So, large wavelength over here, small wavelength over here. Red light, much longer wavelength than violet light. Okay? Questions? as the wavelength decreases, frequency increases. Frequency goes up. Frequency is how many waves pass a point in a given time. 1 second. So here's my example for you, ladies and gentlemen. Are you ready? You are driving somewhere, your car breaks down, you're on the side of the road waiting for someone to come and pick you up. In the far lane, traveling at 65 miles an hour, is one semi-trailer right after another, 18-wheeler. Big vehicle hauling commerce across the United States. Everybody know what I'm talking about. They're all going 65 miles an hour. In the lane right next to you, a Corvette club is going by. One Corvette after another, after another, after another, after another, all traveling at 65 miles an hour. Which one do you see more of, the Corvettes or the semis? Why? Because they are smaller. Same is true with this. Because the wavelength decreases as we go across, but these are all traveling at the same speed, you will see more gamma rays than you will radio and TV waves. Many more. The frequency of those is much higher. The frequency increases as you go across, which means this one, wavelength, lambda, there's your symbol for wavelength, lambda, yellow sheet, lambda.
Is that what, it's like that weird little
That's
upside down
lambda.
thing?
Which is why that's a symbol on there, right? Lambda, symbol for wavelength. Lambda, symbol for wavelength.
What is the E?
E, energy. F, frequency. That, lambda, wavelength. So if wavelength is going up and frequency is going down, what kind of relationship? Inverse. If wavelength is going up, energy is going down. Well, here, wavelength decreasing as we go across, energy increasing. Ones with high frequency have a lot of energy, do a lot of damage. We avoid gamma rays, we avoid X-rays, we avoid UV. We don't avoid radio waves, microwaves, or infrared. Those are the harmful ones, these are not. Those are harmful because they have a higher frequency and more energy. So if wavelength goes up, energy goes down, what kind of relationship? Inverse. But you'll notice that if frequency goes up, energy goes up. What kind of relationship? Direct. Good. Questions?
Wait, so this side has higher frequency and it's dangerous, and this side has lower frequency and it's less.
Low frequency, low energy, long wavelength. High frequency, high energy, short wavelength, dangerous. Go, Sophia.
Okay, so on the sheet, like, you have blue, yellow, and a bunch of colors.
Yep, same pattern.
For it, does it go in the right you did?
That's why we put it this way.
Okay.
High or long wavelength, low energy, low frequency. High energy, high frequency, short wavelength. Same pattern. Same pattern. Good question. Other questions?
What is
Ask him or I'm moving.
ROYG?
Red, orange, yellow, green, blue, indigo, violet. The colors of the rainbow. Thank you. I thought we knew that, but thank you. These are the colors that make up visible light. So my shirt is right here. So when white light hits my shirt, these other ones get absorbed. Blue gets reflected. You see my shirt as being blue.
Wait, what was the orange?
Indigo. Questions? This is what an electromagnetic wave looks like, ladies and gentlemen. By the way, this is the same wave that if you're sitting in the stadium watching a Packer game that some idiot will start. Woo, let's stand up and wave our hands and then sit down. I hate the wave. Okay? I hate the wave. This is also the same wave as you would see in water. The high point of this wave up here, A, that is called the crest. That is on your yellow sheet, ladies and gentlemen. Crest, high point of a wave. Crest, high point of a wave on your yellow sheet. Again, not going to keep telling you. You don't want to write it down, don't. But I would put it on your yellow sheet so that it's all in one spot for you. Yes?
Can I use the study guide
Can you use the study guide on the test?
The review.
Again, open note, open book, whatever you want.
Okay, cool.
Where do you see that?
You don't see crest. They're alphabetical. It's Crestogin. Comes from origin of the name crest. B is the tra. Later on down on your periodic table. Trojan. Bottom point of a wave. Bottom point of a wave.
When you say one that like looks like Trojan horse,
No. I would say the element named after the bottom part of a wave has 16 protons. But you'll know it's trophogen over here, but where the origin of the name is troph on the other side. That's why the origin of the name is over there. So that you don't get it, it doesn't get hidden in that ending of most of the elements in the periodic table. Okay? All right. A here, ladies and gentlemen. 1/2 of the total height of a wave is called the amplitude. Number 1 on your list. Amplitudium. Amplitude is 1/2 the height of a wave. 1/2 the height of a wave. This line right here in the middle of the wave is called the normal. I don't believe it's on your yellow sheet. The normal. A normal line bisects a wave, cuts it in half. And then finally, ladies and gentlemen, this lambda here is the wavelength, the distance of one complete wave. Tra to tra, crest to crest, or one complete wave, however you will measure it. Questions? Good. I will not give you a formula. But from the frequency and the wavelength, you can find C. What's C? Speed of light. What other formula do you know it from? One of E equals mc squared. Who gave us that formula? Einstein. Einsteinium on your list. Einsteinium on your list. E equals mc squared. Einsteinium gave us E equals mc squared, and it relates energy and mass. Correct. Now think about that. Energy is equal to mass times the speed of light squared. What kind of number is the speed of light?
A really big number.
300 million, and we are squaring it. That makes it an incredibly large number, which means the amount of energy you can get from matter is incredible. That's called a nuclear reaction, ladies and gentlemen. C is the speed of light. It's not on your list. You don't have to worry about it. It's the speed of all electromagnetic waves in a vacuum, and it's 3 million meters per second. Frequency is how often something happens. The unit is hertz. Hertz is on your yellow sheet. Hertz is the unit for frequency. Hertz is the unit for frequency, ladies and gentlemen. In my day, it used to be a car rental company.
Imagine
It
we
still
had,
is, I think.
yeah.
Is it?
Doesn't it make like tractors and that?
No, not Hertz. It's a car rental company. And their famous spokesperson, anybody know who it was?
Some football player.
Yes. He became more famous after he was done playing football for being accused of murder. O.J. Simpson.
Oh yeah.
No, and then because they still see the commercials with a different person now, and it's like, I think it's Tom Brady now.
I don't
It's
know.
like, does Tom Brady actually use Hertz?
Ava, go for it. Lambda is wavelength, ladies and gentlemen. That is the symbol that represents wavelength. Unit is normally meters. Normally things like, could be also nanometers, picometers, things like that. Energy is equal to H times F. H is Planck's constant. Planck is on your list, ladies and gentlemen. Planck's constant. H is the constant relating energy and frequency.
So what do we write down?
The constant relating energy and frequency in a wave. The constant relating energy and frequency is Planck's constant. Here's his number. 6.626 times 10 to the negative 34 joules per hertz. What kind of number is this? Incredibly small. Incredibly small.
Do we know?
Okay.
Do we need to know that number?
No, you don't. I'm just giving it to you as a reference.
Do we need to know the formulas?
No, you don't. Because nowhere on your test am I going to ask you to find me the formula for the energy in a wave.
So neither in any of the quizzes.
No,
So is that like the smallest frequency you can get to?
it's not actually a frequency. It is a number that if I know the frequency, I can figure out how much energy there is.
So Planck is how constant's lowest energy.
It is the constant that relates energy and frequency. So in other words, if you take frequency times a number, you will figure out how much energy that wave has. That's what Planck gave us. The constant that relates the two. This is a constant as well. It is the one Einstein gave us for the speed of light. Okay. Questions? For what? You can write down whatever you would like. I'm just telling you what I would write down, which I've said 7 times. Planck is the constant that relates frequency and energy. Energy is in joules. Energy is not on your list. Wouldn't worry about it. Questions? All right, ladies and gentlemen, let's talk about something you know probably very little to nothing about. Mailing a letter.
We know that.
Okay, what do you need to put on a letter for someone to get it?
A stamp and their address.
Okay, what's part of their address?
Their street.
Okay, their street is part of their address. What else?
Their house number.
Their house number. What else?
Zip codes?
City, zip code,
State.
state.
Country.
They have like an apartment.
We don't put
number.
countries on them, right? Unless you're going out of the United States. The apartment number would be part of the number for the thing. The point is, ladies and gentlemen, zip code, state. Let's take zip code out of it. State, city, address, house number. Which of those is the most general? State. The state. So, okay, let's get in the state of Wisconsin, right? What is the next step down after state?
City.
What city are they in, correct? Now, state says, okay, I got an idea on the map where they are. City, now I've got an idea within the state where they are, correct? Then what? The street name, right? Now we've got a street name. Even more specific within that city, correct? And then finally we end with a number. Where on the street is that house, correct? Okay, how many of you have ever been to a sporting event, a Packer game, something like that? Okay, you walk in, what is the first thing you got to find to get to your seat?
The floor that it's on.
Okay, what floor is it on? After that, what do you need to find?
The section.
The section, right? Then what do you need to find?
The row.
The row. Then what? So all of these things begin with something very general and get more and more specific until you have one spot, correct?
Yes.
Well, quantum numbers are that for an electron, ladies and gentlemen. An atom can have up to 118 electrons moving around the outside of it. And each one of them has their own unique location. And this is what quantum numbers are, ladies and gentlemen. They are a way of identifying the location of an atom within, the location of an electron within an atom. So they start out with the real general, and then they get more and more specific, ladies and gentlemen. Now, this is a mathematical model of how you find where electrons are. Now, there is a difference between a mathematical model and reality, and we're going to talk about that as we go. So, every electron in an atom has a unique set of 4 quantum numbers that will describe that electron. No two atoms can have the exact same 4 quantum numbers. Just like none of the two of you have the same exact address unless you happen to live with someone in this room, which I don't think that is happening in here. So you each have your own unique address. Just like each electron has its own unique address, basically. There are 4 types of quantum numbers, each representing something different about the electron. The state, the city, the street, the number. 4 different things describing something different about your address, right? Okay. Each quantum number has a certain set of values it can be. So there are only certain numbers that can be used depending on which of the 4 quantum numbers you are talking about. The first quantum number, the very first one, is called the principal quantum number. That is what the first quantum number is. Now, you're sitting there going, well, Mr. Brand, this isn't on my yellow sheet. You are absolutely right. This is going to be on your quiz on Friday. What does the principal quantum number represent? Well, it represents the energy level. What energy level are electrons in? That is what the principal quantum number represents. Now, we use a lowercase n as a symbol for the principal quantum number. Okay? A lowercase n. Now, when you talk about the energy levels that electrons are in theory, it can be from 1 to infinity. From 1 to infinity. Why? If you add energy to an electron, ladies and gentlemen, you heat something up, you add energy to it. That electron can literally move to a higher energy level. I don't care what level it's in, it can move to a higher one. And if you add more energy, it can move further and further and further and further away. So in theory, you could have an infinite number of energy levels. In reality, ladies and gentlemen, it is the numbers from 1 to 7. Why 1 to 7? You see the numbers on the side of the periodic table? They go from 1 to 7. There are only 7 periods on our periodic table. So when you begin describing the electrons in hydrogen, we begin by saying 1 as the first quantum number because that's the energy level that an electron is in. Okay?
So the periods represent the energy levels?
Correct. The periods on your periodic table represent the energy levels. Okay? And please remember, these 2 down here belong in 6 and 7. They belong in 6 and 7. The period represents the energy level. Questions? So in reality, the first quantum number has to have a value between 1 and 7. That's what it has to have. Questions? So the value of n can only be from 1 to 7, only whole numbers. Only whole numbers, ladies and gentlemen. So 1, 2, 3, 4, 5, 6, and 7. Questions? Okay, good.
So the value of the first quantum number is in between 1 and 7 because those are the energy levels.
Perfect. Questions? Okay, the second quantum number is the energy sublevel. What type of orbital it is in. Okay? It is also called the subsidiary number. That is the technical name of the second quantum number. There is the principal quantum number. There is subsidiary quantum number. Okay? Now, we use a lowercase l to represent it, just like we used an n to represent the principal quantum number. Questions? Now, the values for L depend on the value of N. The values that L can have depend on the value of N. And N can be from 1 to 7. These are different sublevels that have different shapes. So we know that electrons are around the nucleus of the atom. What do two electrons do to each other, ladies and gentlemen? Because of their negative charges. They repel. So we can't have a bunch of electrons in the same space. Why? They repel each other. So these electrons occupy different spaces around the nucleus of the atom. Those are called the subsidiary levels. Okay? Now, the different number of sublevels depending on the energy level. So, depending on what energy level you is, that determines how many different sublevels there can be. Stay with me. The higher the energy level, the more the sublevels. Also, remember, every energy level is where compared to the one before it? Inside or outside? Outside. So they keep getting bigger. So as they get bigger, there is more room for sublevels. Okay? Define this number of sublevels by the integer values from 0 to n minus 1. 0 is a value here, ladies and gentlemen. 0 is an integer. So in the first level, what is the n representing the first principal quantum number? 1. So what are the values from 0 to 1 minus 1? 0. That's it. One sublevel. But if we go to the second level, now 0 to 2 minus 1, what are these sublevels? What are the numbers? 0 to 2 minus 1. 0 and 1. What if it's the third sublevel? 0, 1, and 2. What if it's the fourth sublevel? 0, what? 0, 1, 2, 3. Now, please think about this. First level, what is the number for the subsidiary? 0. Second level, what are the numbers for the subsidiary? 0 and 1. Third level, what are the numbers for the subsidiary? So, in the third level, how many sublevels? In the second level, how many sublevels? In the first level, how many sublevels? Pattern? You bet. So whatever energy level you're in, that is also the possible number of sublevels. The possible number of sublevels. But here's the reality, ladies and gentlemen. We only currently need 4 sublevels. That's it. That's all we currently use. So while you could have sublevels representing 0, 1, 2, 3, 4, 5, 6, and 7. Actually 6, because in 7, 7 minus 1 is 6, right? We never go higher than 3. We never go higher than 3. Okay? Questions? It's not that there can't be higher than 3. We just don't have any atoms right now that need something higher than 3. We will explain why. Questions? Good. But here's the thing. Each sublevel is also represented by a letter. Okay? So, the 0 sublevel is represented by an S. The 1 sublevel is represented by a P. The 2 sublevel is represented by a D, and the 3 sublevel is represented by an F. By the way, while you can use anything on the test, you may not use your computers on the quizzes. So you may want to put this somewhere on a periodic table, one of the many that I've given you.
You said no computers, but what about paper notes?
On your quizzes, you can use the periodic tables and things that I have given you.
So not paper notes?
Nope. Well, if you count this as a paper note, yes. No. But you got to put it on your periodic table or on these.
What do you need the letters that represent each sublevel?
Yes, because those are the important things that we're going to get to in just a few minutes. Maybe not today, but tomorrow for sure. Okay? All right. So, All right. So in the first sub-level, you have a 0. In the second, you have a 0 and a 1. In the third, you have 0, 1, and a 2. In the fourth, you have 0, 1, 2, and 3. In the fifth, you have 0, 1, 2, and 3. You never go higher than that anymore. Even though there's room for a 4, it's 0, 1 through 3 all the way down. Okay. So.
Wait, what's the letter for 4?
I'm sorry?
What?
For 4, 0, 1, 2, and 3.
No, yeah, but I'm talking about the letters. Or are we only using it for? You said we
For
only use
0, it is an S. For L, it is for 1, it is a P. Sorry, that's a 1.
So we don't add 4 into that. So
No, there is nothing larger than this that we need. Nothing larger. Okay. Questions? The third quantum number, ladies and gentlemen, is a number that relates to these different sublevels. Okay? These different orbitals. And it is called the azimuthal number. Now, you're sitting there looking at azimuthal going, what in the heck is that? Azimuthal is the orientation of something in space. Okay? It is the orientation of something in space. So this is what is called the orientation of the orbit. Now, if you were looking at a graph, this ruler would represent what orientation right now? As opposed to this way.
Horizontal?
So what is this? Think of a graphing. X-axis. This is the Y, and this is the Z. We're talking 3 dimensions here, ladies and gentlemen. X, Y, Z. So when we are talking about the orientation, that is what we are talking about, how it is arranged in space. M represents the azimuthal number. N represented the principal, L represented the subsidiary, M represents the azimuthal. The different orientations of sublevel is the space around the nucleus. The value runs from negative L to L. L was the sublevel number, right? So the first sublevel, what number is it? 0. So negative 0 to 0 is just 0. There's only one orientation of that sublevel, and here is why. Look at its shape. What is its shape? Not a circle, 3 dimensions. A sphere. Which means no matter how I change this in space, how does it appear? The same. That's why there is only one orientation of it. You cannot make this in a different orientation because it is a sphere. So the first level, that's what the sublevel looks like. It's a sphere. The second level has a 0, a sphere, but what do you notice about the sphere? It's bigger. Why? Because this has to be inside of here. And the nucleus has to be inside of there.
So the orbital space is the space between the nucleus and the outsides?
The orbital space.
Or the orbitals? Remember the orbitals?
Well, the orbitals are what's in that area, yes. Okay? Now.
Are we gonna need the yellow sheet for the quiz on Friday?
No.
No, we can't.
The only thing you will use the yellow sheet for is your final test. Okay? And maybe a couple practice tests that we'll do. Okay? Questions, ladies and gentlemen? Have a good day.